Namaste everyone, welcome to my class. I am Vinod. We are in 9th standard chemistry chapter 4, structure of atom. So today our topic is electronic configuration. So the last model, successful model about the structure of atom, we have learned the Bohr's model, in which the electrons are arranged in special energy levels or orbits, we call them as. So the arrangement of electrons. Right now, electronic configuration is the arrangement of the electrons or the distribution of electrons in the different shells. So arrangement, electronic configuration is arrangement, or you can also call it as distribution. Arrangement or distribution of electrons in different shells of an atom. So we'll see, when we are arranging the electrons in different shells of an atom, there are certain rules to follow. These rules are given by by Bohr and Bury. So it is called the rule which we have to follow, or which the electrons obey while filling in the energy levels or while occupying the energy levels, is given by Bohr-Bury scheme. Okay, we'll go with this scheme. So there are three important points to remember while writing the electronic configuration or while writing the distribution of electrons in different shells. So we'll go with the Bohr-Bury scheme. So first I will draw this atom with shells. So we'll go with the four shells: K, L, M, N. Then we will have index number for this. I'll write it as N equal to 1, N equal to 2, N equal to 3, and N equal to 4. These are the index numbers. Right now we remember them as index numbers for the shells. So the first, I'll write this Bohr-Bury scheme here. So first scheme is the number of electrons that can be accommodated in each shell is given by the formula 2n square. So that is the maximum number of electrons that can be accommodated in each shell. We'll go with the formula with all the four shells. So here n equal to 1, 2 into 1 square, which is equal to 2. So maximum number of electrons that can be accommodated in the K shell is 2. So we'll go with the same formula, 2 into n square, that is 2 into 2 square. So we have 4 2s are 8. Maximum number of electrons which can be accommodated in L shell is 8. We'll go with the third shell, the same formula applicable to this. So 2 into 3 square, which is equal to 9 2s are 18. Maximum number of electrons that can be accommodated in M shell is 18. We'll go with the same formula for the fourth shell. So 2 into 4 square, 4 for 16, 16 2s are 32. Maximum number of electrons which can be accommodated in the nth shell, and that is the fourth shell, is 32. That is the first rule. So it, and so on it follows. So we have OP. Then we'll go with the second rule in this. The second rule is the maximum number of electrons that can be accommodated in the outermost shell is 8. So this rule is something like which violates what we have learned. Up to here there is no problem, 8 electrons can be, but for the M shell we have 18 electrons. M shell, though it can accommodate 18 electrons, but at any time if it becomes the outermost shell, it can accommodate a maximum number of 8 electrons only. Now if you go for N shell, it can accommodate 32. then also if this becomes the outermost shell, then it can accommodate only 8 electrons. You have to remember this rule, it is very important. And we'll go for the third rule. So in the third rule, it is like sequence. So energy levels will fill from lower to higher. You are going to consider this one lower to higher, or inner shell to outer shell. Something like you have to follow when you are writing the electronic configuration for the electrons for a particular element. What you have to see is, first the shells with lower energy level should be filled first. The innermost shell should be filled. Then we have to follow for the outermost shell. Okay, clear with the scheme? Now we will see some electronic configuration of some elements from 9th standard. In 9th standard, you people have to learn up to 20 elements, the electronic configuration of 20 elements. Since I can't fit all the 20 elements into the length of this board, what I did is I have split up the board into two parts. Right now we'll start with the first element. So I'll go with hydrogen. Hydrogen, whose atomic number is 1. Number of protons and electrons are the same. So we have only one electron. So we have to go with the first shell. K equal to 1. Then, so here what I'll do is I'll write the maximum number of electrons that can be accommodated in each shell. 2, 8, 18, 32. Okay, right now 2 shells can be accommodated in each. Helium, atomic number is 2. So 2 electrons can be accommodated in the first shell. Lithium, electronic number is 3. So 3 electrons. We have to go with in an order. Like first shell, you are going to put the 2 electrons, and the third shell will enter into the second orbit, L orbit. So beryllium, atomic number is 4. 2 electrons filled, then 2 more electrons in the next shell. Boron, 5. Then you are going to put 2 electrons, fill the first shell is, then it goes to the second shell. Remaining 3 electrons will be accommodated in the N shell. Carbon, 6. So first shell 2, the next shell you are having 4 more electrons in the L shell. Then we have nitrogen, atomic number 7. So you have the first shell 2 filled, then we are going to have 5 electrons in the next shell. Then we have oxygen. Oxygen, we have 8 electrons in the 8 electrons. So 2 electrons in the K shell and remaining 6 electrons in the L shell. Then we have fluorine, electronic number 9. So K shell 2 electrons and 7 electrons. So then we have the 10th element, the inert gas, neon. So whose atomic number is 10. The first shell we are going with 2 electrons. Then with the L shell we have 8 electrons. Now be careful when we are going with the 11th element. I'll go to that side. 8 is filled. Check here, the maximum number of electrons that can be accommodated in this is 8. And we go for the second rule also. Anyhow, first rule, it is sufficient. You can't put one more extra electron into this. So we'll go with the 11th element. We'll go with the 11th element, sodium. So sodium, atomic number 11. So first 2, 8. This is 18 and 32. So 11 are there, 2, 8. We have these 2 are completely filled. Now we are going for third shell. 1 electron enter into the M shell. Now sodium, magnesium 12, 2, 8 and 12. This is the 2 electrons enter into the M shell. Then we have aluminium, atomic number 13. So 2, 8 and third electron will be entering into the M shell. Now we'll go for the 14th one, silicon, atomic number 14. Then we have 2, 8, it is 10 electrons are filled. Then last 4 electrons will jump into the M shell. Then we have 5th one, phosphorus, 15, 2, 8, 5. Then we have sulfur, 16, 2, 8, 6. Then we have chlorine, 17, 2, 8, 7. Now we are coming to one more inert gas, argon, 18, 2, 8, 8. Okay, from here we have to be very careful when we are filling up. Next two electrons, potassium and calcium. So we'll go with potassium and calcium. Potassium has atomic number 19. So it is 2, 8, 8. Array, this can accommodate 18 electrons. Then why did I stop at 8? You see, we have the second rule in Bohr-Berry scheme, that is, at any time the outermost shell can accommodate a maximum number of 8 electrons. Now for potassium 19, this if I put 9, then that becomes M shell will become the outermost shell. It cannot accommodate more than 8 electrons, so it is going to violate that rule. So 8 electrons are maximum, then the next electron occupies nth shell. So I am going to put here 1. What about calcium? Calcium atomic number is 20. Then we have 2, 8. Why can't I make it 9 here? Because anyhow outermost shell I got 1 electron. Then also we are going to put it as 8. Then the 2 electrons are going to enter into the nth shell. Right now last two are a bit confusing because you people don't have idea of subshells or another information about the quantum numbers of these elements or the electrons. So for you to remember, for right now in simple words I'll say, now I'll rub this part of the board. We'll go with M shell and N shell. As the number of electrons keep on increasing, the energy of the M shell increases as the number of electrons keep on increasing in the M shell. Then the energy of the M shell increases. Right now, when M shell has 8 electrons in the outermost shell, the energy of the M shell will be greater than N shell. So what happens? So the electrons are filled in the order of energies. So M shell after gaining 8 electrons will have more energy than the N shell. So the electrons starting entering into the N shell. Now 1 and 2. Once the 2 electrons are filled in the N shell, immediately the N shell goes to the higher level. N shell will go for the higher level once 2 electrons are filled. So right now we have 1 electron for calcium, another electron for potassium. Once these 2 electrons are filled, so we are going for, I'll write one more element so that you will understand. For scandium, the 21st element, we are going to write 2, 8, and since after gaining 2 electrons, N has attained higher level, this will become 9 and this is 2. So 2 plus 8, 10, 19, 20, 21. This is how the electronic configuration will be. For right now, you remember like this. Okay. Thank you everyone. Hope you understand. So we'll meet with the valencies and valence electrons in the next session. Thank you so much.